In this video, we are given the standard form equation of several conic sections. They might be circles, parabolas, ellipses, or hyperbolas. I'm going to show you how to graph them and label them with their key pieces of information. So at a glance, we can tell this is the equation of an ellipse. I can tell because it has the plus in the middle. When you have a fraction plus a fraction equals 1, it's going to be an ellipse. So the center will be the opposite of this and the opposite of that. So 3, 2. So here is the center at 3, 2. Next, let's find the vertices. Let's start with a squared. For an ellipse, the bigger number is always a squared, the bigger denominator. So a squared is 9. So a is going to equal 3. Notice that the 9 is the denominator of the y term. So I will do my plus or minus 3 in the y direction. So I will do up 3 and I will do down 3. These are the vertices of the ellipse. So they probably ask me for these. So this lower vertex is 3, -1. And the upper vertex is 3, 5. All right, we found that the a value is 3 and the center was 3, 2. So let's write that down. Noticing that the vertices are vertical, we can say that the major axis is vertical. All right, let's go ahead and find the b value and the co-vertices. Well, the smaller denominator is going to be b squared. So that means b is equal to 2. Notice that the 4 is the denominator of the x term. So I will do my plus and minus 2 in the x direction. So these will be my co-vertices. 1, 2. And 5, 2. All right, and my b value was 2. Now I need to find the c value and the foci. I feel like I should go ahead and draw the ellipse now, because once you have the vertices and the co-vertices, it's easy to draw the ellipse. So let's go ahead and take a look, shall we? So there's our ellipse. Now, to find the foci, we need to recognize the relationship between a, b, and c. C squared is equal to a squared minus b squared for an ellipse. So c squared is equal to 9 minus 4. So c squared is equal to 5. So c is equal to the square root of 5. So the approximate value of c is 2.2. So c is the square root of 5. Okay, if I go up 2.2, that's going to be about here. If I go down 2.2 from the center, that's going to be about here. So these are the foci. Now when I label them, I have to use the radical 5 though. So the x-coordinate of these foci is clear. The x-coordinate is 3. All right, same as the x value of the center is 3. So I know these will be 3, something. So the foci will be 3, something and 3, something. I have to be a little bit more careful about the y value because it's between the lines. What you want to do is start with the y value of the center. So the center has a y value of 2. So I'm going to start at 2. For the upper focus, I'm adding something. So I'm starting at a y value of 2 and I'm going up. I'm going up by the value of c. I'm going up by radical 5. So that's why I'm going to do 2 plus radical 5. Similarly, for the lower focus, I'm starting at a y value of 2 and I'm going down radical 5. So I'm going to start at 2 and I'm going to subtract radical 5. So these are the coordinates of the foci. At a glance, I know that problem B is a hyperbola because of the minus in the middle. I know that this will be a vertical hyperbola with branches opening up and down because the y term is first. So I know it'll be vertical. Let's go ahead and say what the center is. The center is going to be the opposite of these coordinates. Okay, let's just write this down, the center. But we have to be careful. The x-coordinate of the center is going to come from the x part of the graph. I will do the opposite, so it'll be -3. The y-coordinate from the center will come from the y part of the equation, not the graph, the equation. Since nothing is being added or subtracted, I know that the y value is 0. So the coordinates of the center are -3, 0. Let's go ahead and write that down. -3, 0. And let's graph it. So -3, 0 would be right here. Now let's go on to find the vertices. For the vertices, I need to find the a value. For a hyperbola, a squared is always first. It doesn't matter which one is bigger. It's whichever one is first. And it should always be positive in standard form. If a squared is equal to 1, then a itself is also equal to 1. Notice that this 1 is the denominator of the y term. So I will do plus or minus 1 in the y direction. So starting from the center, I'm going to go up 1 and down 1. These are my vertices. So this is -3, -1. And -3, +1. Okay, and the a value was 1. Let's go on and find the b value so we can get the covertices. B squared will always equal the second denominator, the denominator of the negative term for a hyperbola. So that means b is equal to 2. Notice the 4 is the denominator of the x term. So I will do plus or minus 2 in the x direction. So I will do right 2 and left 2, and these will be my covertices. So that's -5, 0 and -1, 0. Okay, and that b value was 2. So the transverse axis is vertical. The transverse axis is the segment connecting the vertices. So this is the transverse axis right here, and it is vertical. Okay, I'm going to save the c value and the foci for later because I would really like to go ahead and draw this hyperbola. So once I have the vertices and covertices, I want to draw a rectangle. Okay, I'm going to draw the rectangle that passes through the vertices and the covertices. Okay, draw it as a dotted line. This rectangle is important because it reveals the asymptotes. The asymptotes will pass through the diagonals of this rectangle. So here's an asymptote. And here is another asymptote. If I can grab it. All right, so the rectangle reveals the asymptotes. So I'm going to go ahead and draw my hyperbola now. The hyperbola will, of course, start at the vertices, which are these red dots. Then they should approach the asymptotes. So make sure your branches of the hyperbola get very close to the asymptotes. All right, they should be approaching the asymptotes, so draw them getting closer and closer to the asymptotes. Okay, mine got a little janky in there, but this can be tough to do with an electronic pen, so I hope you'll forgive me. So this is what your graph should look like. Now I'm going to go ahead and find the foci or foci. To do that, I will need the C value. And you know what? I'm going to also write the equation of the asymptotes, even though they didn't ask me for that. So for the foci or foci, I know that the relationship is c squared is equal to a squared plus b squared for hyperbolas. For ellipses, this is a minus. For hyperbolas, it's a plus. It's kind of the opposite of what you see in the standard form equation. So c squared is equal to 1 plus 4. So c squared is equal to 5. So c is equal to the square root of 5. Ha, that's what it was last time. So c is radical 5, which again is approximately 2.2. So the foci should be in the interior of these branches. So if I go up 2.2, there should be a focus. If I go down 2.2, there should be another focus. When I label these points, though, I have to use a radical 5. This time we're starting from 0. So if I start from a y value of, well, the x coordinate is going to definitely be negative 3. These points are both to the left 3. So let's get that out of the way. So we know we have negative 3 comma something and negative 3 comma something. It's just a matter of what's the y value. Well, this time we're just plain starting from 0 and we're going down radical 5. So that'll just be negative radical 5. And if we go up radical 5, that'll just be positive radical 5. Now, I'm not sure why they didn't include this on the list, but we also want the asymptotes. Okay. Now, the model for the equation of the asymptotes will always be like this. Y minus k is equal to plus or minus the slope times x minus h. H and k are the coordinates of the center as usual. So, noticing that the center is negative 3 comma 0. 0 is the k. So I'm just going to have y equals plus or minus. Now it's time for the slope. For the slope, look at your rectangle. What's the rise and the run from the center to the corner? Well, it's up 1 over 2. So that's 1/2. So I'm going to have plus or minus 1/2. And then x minus h. So that's the opposite of this. So I'm going to put x plus 3. So this is the equation of the asymptote. Actually, it's the plus or minus means it's the equation for both asymptotes. Plus for the uphill asymptote and minus for the downhill asymptote. I can tell that part C is the equation of a parabola. And I know that because only one variable is squared. Y is squared, the x part is not squared. So in standard form, I really want to have the squared part by itself. So this 1/8 is in the wrong place for me. So what I'm going to do is I'm going to multiply both sides of the equation by 8. That way this is going to be gone. Okay, so if I rewrite the equation, and I'm going to write it so that the squared part is first, because that's what we're used to. This will become y plus 2 squared is equal to 8 times x plus 3. All right, this is the way we're used to seeing it. So I know that this is going to be a sideways parabola. Whenever I see that the y part is squared, I know it's going to be opening either left or right. So because the 8 is positive, that means it's opening to the right. So I'm looking for a parabola to be shaped this way. It's opening to the right, which means I'm going to have a focus in the interior and a vertical directrix to the left. Okay, and the vertex is this point right here. So let's start with that vertex. What are the coordinates of the vertex? Well, it's going to be the opposite of these two numbers, but be careful. Maybe I should just write this down. Vertex. The x-coordinate of the vertex comes from the x part of the equation. So yes, I'm going to do the opposite, but the negative 3 comes first. And then the negative 2 will go second. All right? The y-coordinate comes from the y part of the graph. So that's the vertex. Negative 3 comma negative 2. All right? Remember that this will be opening to the right. Next, we need to find the focus. To find the focus, we need the p-value. So what you need to understand is that this number right here is 4p. So in other words, 4p is equal to 8. If I divide both sides by 4, I get p is equal to 2. So I knew right from the beginning that the focus would be to the right of the vertex. Now I know that the focus will be exactly 2 units to the right. So the focus will be here. All right, so the parabola will open around this focus. The directrix should be the same distance to the left, a vertical line. So if the focus is 2 units to the right, the directrix will be 2 units to the left. So there's my directrix. We need 2 additional points in order to graph this parabola. So for that, we're going to use something called the focal width. All right? The focal width is going to come from this number right here. So the focal width is 8, but just understand if this number had been a negative 8, the p-value would be negative 2, but the focal width would still be positive 8. The focal width is always positive. Anyway, the focal width is the width of the parabola at the focus. So if the focal width is 8, that means if I go up 4 and down 4, that will give me a total width of 8. So I now have enough points to graph my parabola. Okay, so your parabola should look a lot like that. So let's see, what are they asking us for? The equation of the directrix. That's a vertical line at negative 5. Vertical lines are always x equals something. So x equals negative 5. The vertex, it was at negative 3 comma negative 2. The p-value was 2. The focus is right here at negative 1 comma negative 2. Oh, all right. They want the directrix equation down here. I now see. Up here, I was just supposed to say whether or not the directrix was horizontal or vertical, and it is vertical. Okay, so that's all they asked me for on this problem. But be prepared to say the focal width as well. Okay, I believe this is the last problem. I can tell that this is going to be a circle because both squared terms are positive and they have the same coefficient, a coefficient of 1. So that's how a circle works. So we need to group together the x terms, and we need to group together the y terms. This -2 needs to get to the other side of the equation. So I'm going to have x squared minus 6x plus y squared minus 10y is equal to 2. There's that 2. Notice how I'm leaving space to complete the square. Completing the square, we do half the middle squared. Half of this is 3. 3 squared is 9. So I add 9 to both sides. Half the middle squared. Half of this is -5. -5 squared is positive 25. So I add 25 to both sides. If I factor this, I'm going to get x minus 3 twice. So x minus 3 squared. If I factor this, I'm going to get y minus 5 squared. So I just got to add all this. All right, that turns out to be 36. So this is a circle that has a center of 3, 5, the opposite of this and the opposite of this. So the center is 3, 5. This is the radius squared. So that means that the radius is 6. Okay, so if the center is at 3, 5, that's going to be right here. Now if the radius is 6, that means if I go 6 in all directions, I should be hitting the circle. So all I need to do is draw a circle containing these points. And there you go. So that's it for part D. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.